In this next section, we will look at physical and chemical changes. So we've looked at physical and chemical properties, and now we will look at physical and chemical changes and how these are different from the properties. So in a physical change, the substance remains the same substance, but it may change form, state, or even dissolve. What it means is the particles are the same particles, and oftentimes students get this mixed up because they think it's the same substance, so it couldn't possibly have changed. An example of that is when we toast bread. Students will say, well, it's still bread. No, it's actually toast now. It has changed substances. So when it is not the same at the particle level, it is not the same substance. So some examples where the substance remains the same: ripping paper, breaking glass, or crushing stone, all changes the form of the substance. Changes the form, but it's still the same substance. It's just the ripping paper, it's smaller pieces. Breaking glass, smaller pieces. Crushing stone, smaller piece. But if you look at the particle level, it's still the same substance. Another example of types of physical changes are when they change the state. So at the particle level, it's the same, even though it may not seem like the same thing. When you melt gold, for example, it's still gold particles. Or evaporate water, it's still water particles. So it's the same substance. And even if water becomes solid, it's still water particles. And lastly, dissolving. When the solvent particles are spreading out, whenever there is dissolving, this is a physical change. So it may seem like the sugar disappears in the water, but the sugar particles are still there. And carbon dioxide, when we dissolve that into pop, that's usually one place we do. That's what gives the pop its fizz. Right? So it is dissolved inside the pop, which is why when you open up a pop, it makes that psh. That means it's releasing the carbon dioxide out of the pop. Makes a bubble. So those are some examples of physical changes. Chemical changes happen when a substance is changed into a different substance with different properties. So we're making new substances. So the particles of the new substance are different from the original substance. So I give that example of burnt toast. When a nail rusts, again, students will say, well, it's still a nail. Well, part of it has changed now to rust. It's no longer the same. And maybe you've not heard of Alka-Seltzer. I've put a little video of what Alka-Seltzer is. It's when you have a sore stomach. It bubbles in the water. So in all these cases, you end up with a new substance. So how can we tell if it's a physical or chemical change? Well, we have some clues for chemical changes, and they are only clues. They suggest a change, but don't necessarily mean it's true. But we have to put together our prior knowledge sometimes and observe the situation, and with experience, we will learn more and more which are physical and which are chemical. So a new color appears. Heat or light is given off. And sometimes it's with heat or light given off, it's a temperature change. So you might see it gets colder too. It might start off as one temperature and then get colder, like a cold pack. Right? That's a chemical change. So in case you always think it's heat, it's not always heat. Some chemical reactions need heat to happen. Some release heat or energy, sorry. Some need energy, some release energy. That's a better way to put it. Bubbles of gas are formed in some in chemical reactions sometimes. Sometimes bubbles do not mean chemical though, right? You could probably think of an example. Did you think of boiling water? Because that is an example, yes, where it's a physical change, not a chemical change. Solid material forms in a liquid. We call that a precipitate. And so an example of that would be for a precipitate. Like think about when milk goes bad. Goes bad. It gets kind of chunky, right? That's like a precipitate forming. That's the precipitate. And the change is difficult to reverse. So not always impossible, but some are impossible really. I mean, you can't unburn a piece of toast, but some reactions are reversible. Can you think of one? You'll have to tell me in class. So just remember that because a clue is seen, it doesn't mean it's definitely a chemical change. It just suggests a chemical change. Okay, so that's the end of that lesson. Have a great day.